Okay, so when the client sends a certain request to the nearest switch or access point, the switch will decide whether uh, it will send the data on its own in the optimal route to the destination, or else whether it will ask the controller whether that controller can provide the optimal route to the destination node. So as you know, like the network that we connect to is a wide area network. And if we want to send a data from our location to geographically distant location, then our data has to travel a long distance, and our data has to go through the public internet. And this public internet is a massive network, and sometimes we don't even know how our data will be routed inside the internet. The complexity of the internet is very high, and as the time goes, the devices keep accumulating into this network, and its complexity gets increased. And therefore, a certain switch in the network, if we take this switch, for example, and individually each of these switches might not be able to decide what is the optimal path to send a certain data from one location to another location. In that case, this controller, which is used in the, that we define for the software-defined networking technology, is going to be a help. Like controller is the component which knows the topology of the entire network. It can understand, okay, like how the routers and switches are connected to each other. So in this case, they have considered a local area network, and that local area network, how the communication happens. And in the local area network, the controller has the total idea about the network. It knows like how how the devices are connected to each other, and also the current data traffic in the network, and what are the links that are not working, which paths are more reliable to send the data, and so on. So because of that, the controller has a wide knowledge or deep knowledge about the network. So the switch can ask from the controller to give the best route to send the data along. And the controller will provide the information to the switch. And also the controller will enable the data communication to happen by deciding the optimal path to send the data. So if it decides that the path should be from the first switch to this switch, and then to this switch, and then to this switch, and then to this switch, then the controller will give commands to each of these routers, and like update the like flow tables in those routers. Those routers have flow tables, and those flow tables enable those routers to understand easily to which router they need to forward that data packet. So in order for the for that to happen, the controller will update the tables that are available in each of these routers. So the routers just have to check their table and send the data packet to the necessary router. And so each of the routers will check their table and send the data packet to the indicated router, which is optimal. And then each of the routers will forward the packets as following the flow tables. And then the data packet will be sent along that route. So that is how the controller will control the traffic in the network. So last week we talked about that scenario, and we actually stopped at, I think, in this position. So we talked about how the controller can give commands to each of the routers in the network, and also the controller can remove some like some switches, I mean the flow tables regarding some switches if a certain switch is not linked to the network anymore. So if there's a switch whose link to the network is broken, then that switch will no longer be active, and that switch will not be useful anymore. In that case, the controller will remove the record of that switch from the records it has, and it will only keep a count of all the active routers in the network. And also uh, there's some benefit in centralizing the connection request by the controller, right? So there's some benefit of using this controller. So one of the benefits is that once there are some kind of connection requests by outsiders from the network, the controller can easily understand that request is from an outside person or outside router, right? So only these routers can send connection, I mean, request to the controller. Only the routers which are already configured in the network can send connection request to the controller. However, if there's any kind of outside like router which is totally foreign to this network, if that router is adding like connect some I mean sending some connection requests or some kind of request to the controller, the controller will know definitely, okay, there's some strange or intruding router in the network. Also, the controller will ignore such requests from that kind of router, and also will inform the other routers in the network that there's some kind of intruder. Also, the network traffic that is added by this router can be ignored because of by this controller, because of the presence of this controller. The controller knows that this kind of a router is a intruding router. So therefore, the actions or requests by this kind of outside, I mean, false or intruding routers can be like ignored by the controller. Because the controller has the full knowledge about the topology of the network. And because of that, the denial of service attacks can be dropped. So what do you mean by the denial of service attacks? So that means that if sometimes when there's a lot of traffic in the data, I mean in the network, so if there's a lot of traffic in some kind of a area in the network, then the routers assume that some problem has happened in the network and the network service has gone down. However, it is not the real case. It's because of some outside like routers, intruding routers, adding more traffic to the network. In that case, the legitimate or the real traffic that needs to be sent from one source node to the destination nodes do not get sent correctly. So because of that, communication problems occur. However, now if we have a controller, then we can identify that there's some kind of intruding router which is adding this unnecessary traffic. So if some router is adding some unnecessary traffic, then the controller will identify that, and controller will ignore the request of such kind of routers. The controller will not allow that router to connect to the rest of the network. And also it will help to reduce any kind of like data traffic that is added to the network, which unnecessarily, right? Unnecessary data traffic that it added to the network will be reduced. So only the real traffic real data traffic will be forwarded from one router to another router, and so on. So that is one of the benefits of software defined networking and the controller, having the controller. Then as you know, like we have like networks which are large in in size. So when the network size gets larger and bigger, then we need to divide the network into multiple sections, and we need to assign different controllers for each of the networks. If we have a large network, we can divide the network into several sections, and we can give one controller for each of the sections, and the other controller for the other sections. And we can define like what is the area that certain controller is responsible for, right? We can assign some set of routers and switches to one controller, and we can assign a set of another routers and routers for another controller. So apart from that, each of these controllers can also communicate within each other, and they can synchronize their information. And by that, they can understand the total network topology that is under consideration. So if the certain client want to communicate with another certain destination node, which we can take is here, if the destination is here, then the source node can go through the switches of one like one control and one plane to another plane. So it needs to travel through multiple planes and reach the destination node. In that situation, the details available in one controller will be passed to the details that is there in the other controller. So other controller will obtain information about any kind of requests that are made by a certain client, and based on that, the controller will understand, okay, this is the destination node that the client want to access. So based on that, I need to route the data accordingly. Likewise, the controllers can talk with themselves and decide the optimal path to send the data from one point to another point, right? So the controllers can work together and decide what is the optimal path to send the data from one source point to a destination point, right? So that is kind of the flexible way of managing the data traffic. So basically, so we have talked about the software defined networking technology. So there are multiple benefits that are available under this technology. So the first one is its cost effectiveness. So rather than using multiple like switches and routers which are defined for the routing task and sending data forward, we can use cheap inexpensive switches and routers with little like software and processing ability to as routers and switches in our network, where the controller will do most of the tasks of related to routing and forwarding data packets, right? So earlier we had to use special or specified uh, hardware and software for sending data packets from one router to another router along the network. However, now we don't need specified hardware and software. We can use the available, switches and routers, which are inexpensive, which are not specialized. So we can use general routers and switches to build our network infrastructure. And we can use those general, routers and switches to send the data, in the optimal manner. So SDN provides cost effectiveness by reducing the cost that we spend on buying specialized hardware for our network. So once we are using SDN technology, we do not need specialized hardware to do our data forwarding functions. We just need the general routers and switches. We can configure them to work according to the way we want using the controller in the software-defined networking technology. So also we can achieve reliable routing. So as you know, like in SDN technology, we have a centralized controller who has the total idea about the entire network. Because of that, once a certain like router wants to send some data to some other location, then uh, like we can decide the optimal path to send the data, right? Rather than deciding at each hop what is the best method to send the data forward, the controller will decide, like before sending the total data, the controller will decide the optimal path by looking at the total network topology. So the most reliable route will be decided beforehand, and then the data will be transmitted. So because of that, the reliability of sending the data and reliability of the route that we select is high. So reliability of the data getting, reliability of the communication will be very high, because we have reliable path to send the data from one end to the other end. And we also ensure that there are no link failures or any kind of problems in the route that we select. Also, we select the most optimal path, like the most shortest path. Likewise, we choose the path with the less data traffic. So because of that, the ability for our data to be lost or the ability for our data to be delayed is less. So because of that, we can call that the reliability of the communication is high. Then service quality again, service quality is maintained here. So service quality can mean different things. So if we take, actually we can take, for example, like the quality, for quality we can take the latency and the bandwidth, or resources, I mean packet losses we can take, right? The latency, packet losses that can happen can be minimized using the software defined technology, right? So as I said before, the latency can be reduced because we are choosing the best path to send the data forward. So we can choose the path which has the the least data traffic. So if you are sending path data in the least data traffic path, then our data packet can quickly move from one router to another router, and from that router to another router. Likewise, it can go through the least traffic path. Apart from that, once it's happening, the packet losses that can happen is also low. Because of that, the data packets will reach very quickly to the end destination. It will not be lost, and the customer will get continuous data. And if such kind of data packet losses happen continuously, and if there's a latency, high latency, then the customer will not be satisfied with the quality of the service. So that is what we mean by maintaining quality of service. And therefore, like using SDN, we can improve the quality of service of the that is experienced by the customer, and we can actually respond very quickly to the application requirements. And security of the system can also be enhanced. So as we discussed earlier, we actually um, we wait. Okay, so the security of the SDN relies on how it can prevent some jammers or intruders uh, coming into our network, sending their data packets into our network, right? How fast we can identify such kind of intruders, how reliably we can stop those intruders sending their data into our network, and how we can stop them from modifying any kind of data that we send in our network. So security means like how we can prevent any kind of damage that can be done to the data that we are sending through the network. So if we have a secure system, then we can stop any damage or any kind of problem that is occurring to the data that we are sending through the network. So in SDN networks, as I mentioned before, we have the controller who has the total, idea about the total network. So because of that, if there are any strange routers or switches that is sending some requests to add to the network, connect to the network, then the controller will understand, okay, this is not a device which has been configured previously into this network, and therefore it is a suspicious device. Therefore it will not connect it will not connect the device directly to the network. So it will first run some configuration tests, from some authentication test, and only if the router is shown to be an authenticated device, it will be added to the network. Otherwise, the controller will not allow any kind of unauthorized routers or switches to connect to the network. And apart from that, any kind of requests sent by such kind of routers will not be addressed by the controller. And also any kind of switches or routers that are there in the network also can act as simple firewalls at the edge, right? So the reason is the routers and switches are also connected to the controller, and the controller will like check the validity of the request that the client has made, and whether it's authorized, or whether it's a legitimate request, and likewise it will check before allowing the data to enter into the network. So the each of the routers or switches also can act as simple firewalls at the edge of the network, and can prevent any kind of suspicious data entering the network. So if you have any questions, please ask. Okay. So most of the content that I have covered under SDN is now, I think, sufficient for the software defined networking. So there are multiple companies who are using the software defined networking technology. So Google, Facebook, Microsoft, Yahoo, Verizon, and some other companies have already started using software defined networking. However, there have been cases where the software defined networking technology also has failed a little bit in terms of its performance, right? If something happens to the software defined networking controller, then we might even lose connections to some of the routers in the network, and therefore some kind of data centers and local servers that are connected to these routers will also not function properly. So recently there was a blackout by Facebook in some situations, some areas in the world, and because of that we have lost connection to the Facebook, Instagram, and so on. And this has it is like estimated that, it is said that it is because of the SDN technology that they have used, and some error in the controller mechanism, in the controller, that uh, cause this problem. So if there's some problem that that is there in the SDN controller, then like the communication will be affected. So using SDN is a good idea, but however, we need to make sure that the SDN controller is functioning very well if we are using SDN controller technology. Apart from that, SDN technology can be widened further using SD-WAN technology, software-defined wide area network technology. So in that technology, what we mean is basically we have different local area networks which we want to connect to each other. So these different local area networks are in different countries, for example. So if this is in kind of USA, then another one could be in Japan, another site could be in Sri Lanka, and another site could be in Mexico or some other country. So we can use the software-defined networking to connect and control each of the local area networks in each of the countries by using one controller. So the controller based functions enabled components are there in this white box. In this white box, we have the total functions of the controller, and this controller is able to control the network traffic in each of these local area networks that are there in different locations in the world. And the controller is able to configure any of the devices in any of the networks. For example, if we want to connect the USA site to our like SD-WAN network, then we can connect our devices to the components which are connected to the controller. If we can go through the internet and connect, if we connect through our internet to this controller, the controller can configure these components through the internet. So, so that is also known as one of the advantages of this SD-WAN technology, which is that the controller is able to configure even each of the components in each of the local sites using through internet, and it can do the configuration through the main controller. So manual configuration at the local level is not required. We can configure the devices centrally from a central point. It is very easy now. We just need to connect our devices to the internet, and through the communication request we are sending to the controller will configure each of the devices which are newly added to the network. So the software-defined networking in overall provides a lot of benefits to us. So main benefits include cost saving and agility, flexibility. It's adding and reducing the downtime. Right. So cost saving, as I mentioned before, means that we do not have to use specialized hardware to use the software defined networking technology. We can use the general routers and switches with less processing ability and with less software ability. We can program them, however, to function with the software-defined networking technology. So in the software-defined networking technology, the brain or the main work is done by the controller. So the controller needs to have high processing power. It needs to have high ability, software's ability and so on. So it needs to have high resources. However, the routers and switches that are there to forward the data does not need to have high processing ability and high functionalities, and therefore we can use the general routers and switches for the data forwarding. And with each service updates, we do not need to update the hardware, and because of that we can save a lot of hardware costs. And then we can also improve the flexibility of the system. So that means that once we have certain requests from a certain client, we can select the optimal path to send the data. So based on the optimal path, the data traffic in that optimal path will be lesser than the normal routes, and therefore the speed of the data transmission will be high, and the link downtime will be low. So what we mean there is that the controller will be able to identify which path is the best by checking all the down links. I mean, the links which are not connected to, correctly or reliably in the network. And based on that, it can send the data forward in the most reliable route. Apart from that, it can also inform the necessary locations to rectify these faults. Right. So basically, those were the things we have covered in the software defined networking section. So these are some of the abbreviation terms we have gone through in this section. So API means application programmable interface. I think you need to check this one a little bit. So this word might not be correct. Programmable, I think it should be application programmable interface. Command line interface is CLI. Graphical user interface is GUI. Machine to machine is M2M. Network function virtualization is NFV. Point to point is P2P. Software defined networking is SDN. Software defined wide area network is SD-WAN. A virtual machine is VM. So as a summary, I would like to mention in roughly what we have discussed in this section. So basically regarding network virtualization. So network virtualization can be divided into two parts. So first of all, network virtualization is basically using softwares to uh, uh, get the uh, to using software to do networking functions. So using softwares to do networking functions. So so the networking functions can be divided into two basically: controlling the data traffic and sending the data traffic. So controlling the data traffic can be done using the software defined networking technology, SDN, and uh, sending the data forward and doing other networking functions can be done using network function virtualization. So network function virtualization can write software programs to do functions like routing, firewalling, um, load management, uh, and so on. So any of the functions, network functions that are performed by routers and switches can be implemented using softwares. And then we have software defined networking, which defines a controller which controls the uh, data traffic in the network in the optimal manner. So those kind of technologies actually save the cost, increase the reliability of the communication. That means like how reliably we can receive the data with low latency and with less packet loss. And so therefore we can increase the quality of service. Then we can also increase the security of the communication. Uh, the SDN technology can increase the security of the communication. The controller which is used in that can identify intruders in the network and prevent such kind of intruders entering, adding that data traffic, adding some traffic to the network. So likewise, we can have several benefits from the software defined networking technology. So now we will talk about the next section. We will go to the next section. So if you have any questions, please let me know. I think if you have any questions, you can let me know. So in today's class, we will go through the network slicing technology. So basically, we will be talking about uh, uh, kind of like an extension of the SDN and network virtualization section. So network slicing will be the second part of the network virtualization lesson. So network slicing is very related to network virtualization. So we will talk about that in this class. So network slicing is a concept which is widely used in research works in the telecommunication field and also in other domains. So network slicing is very popular because it is expected that it can provide high data rates and like user specific requirements by creating individual slices, right? Creating individual slices for each application. So if we take, for example, like there are some customers who are connected to our network who need different requirements, who has different requirements. So customers have different requirements. Some customers might need high data rates, right? Some customers might need high data rates. Some customers might need low latency, right? So if some customer needs low latency, then um, there's that is another specific requirement. Apart from that, some customers want to connect multiple devices at the same time, like about 1 million devices at the same time, right? In that case, the service provider, communication service provider, face some difficulties because different devices want different data traffic, different data rates, different quality of service. So since the telecommunication service provider cannot like provide services in that manner directly, it has now come up with the network slicing concept, where the network slicing concept will create virtual, independent, and end-to-end networks or slices, right? Within the physical network infrastructure, um, to provide for different services required by the customers, right? So we will take one example in the class and we will clarify this further, so don't worry. So we will be basically creating slices to address different applications of the customers, so different customers can have different requirements. So as I said before, if there's if there are three types of customers, we can take basically three types of customers. So one customer want high data rates. Let's say just for this moment we will take like this. Another customer want low latency. Another customer wants massive connectivity. So based on these requirements, the telecommunication service provider will provide a certain set of resources for this person, right? And that is known as a single slice. So slice one will be allocated to this. We'll say this is A, to a certain set of customers who want high data rates. Slice A will be created, right? And then slice B will be created for the specific application which requires low latency. So then we will have another slice where we want massive connectivity, right? So this massive connectivity is very unique to this module, because IoT means a massive connectivity application. So Internet of Things will require massive connectivity. So therefore, for Internet of Things, we will require certain separate slice, right? So if the communication service provider can provide us a separate slice for our application, which could be IoT, then we can send our data through that slice. That slice will contain the resources that we require to send the data, right? So the slice will contain the RAN or random access network, the transport layer, right? So the random access network is required for our devices to connect to the network. After that, we will have a transport layer through which our data will be sent through as packets through routers and switches. And then the core network. The core network will receive the packets, and the core network will connect our data packets to the necessary destination. So once we have a separate slice, we will have a separate RAN. I mean, it is the logical understanding about this uh, slice concept that we will have a separate RAN, we have a separate transport, and we have a separate core network. Right? However, in reality, we only have one core network, and we have one transport. I mean, some hardware for the transport layer, and the random access network also will constitute of, I mean, a common random access network provided for all the different customers. However, we can logically like plan the communication in the network such that the communication of different applications will be treated differently by the network, right? So we will consider about that later. Anyway, for different application types, we allocate a different slice. So for high data rate applications, we allocate a slice called A. So any customers who are connected to this high data rates application will be using this slice A. And any user who's going to use low latency and ultra reliable communications will connect to slice B. And any user who's connecting to the massive connectivity application will connect to slice C, and so on. So likewise, we can have different slices for different applications. And one question you can ask is like, can't we have two applications connected together? Can't we have high data rates with low latency? Can't we have low latency and massive connectivity, both combined? Yes, we can. We can create such kind of application instances where there's a combination of uh, one or two of these kind of um, performances, right? So high data rate performance or low latency performance or massive connectivity performance, right? We can have combinations of these kind of performance, and we can design our slice according to that. So this is one diagram that shows how slices are differentiated for each of the applications. So for enhanced mobile broadband communication, we have a separate slice. Okay, so enhanced mobile broadband communication means high data rate applications. So enhanced mobile broadband means high data rate instances, right? The applications which require high data rates, we call high data rates, will be served using this enhanced mobile broadband service. Okay, so using the enhanced mobile broadband service, we are going to serve high data rate users or customers requiring high data rates. So what are the examples of high data rate customers? So in the coming future, we are actually expecting the use of augmented reality, right? AR we call augmented reality, right? Where we use augmented reality or virtual reality to see our surrounding and like use 3D virtual like environments to see like something happening somewhere else, or else just imagining some other scenario through our equipments, right? So already Facebook and other companies are going towards AR glasses, and AR headsets. So those headsets and glasses require high data rates. So they require more than like gigabits, I mean 20, 30 gigabits of bits, gigabits per second, or very small time. And also we require high data rates for CCTV and other kind of entertainment applications. So these applications will require high data rates. So for those applications, a separate slice will be allocated by the telecommunication service provider. And then when we take URLLC slicing, URLLC means like ultra reliable low latency communications. Ultra reliable low latency communications. In that case, we have to maintain reliability and latency of the communication. So, so one example of this situation is vehicle-to-vehicle communications. So vehicle-to-vehicle communications have to have ultra reliable and low latency communications. So the communication data must be reliable, and the latency of the communication must be very low, because otherwise the vehicles will not be able to do the necessary decisions on time. So in the future, already I think some vehicles are autopilot. That means some vehicles are driving on their own in the road. So when normal people are driving in the road and other autonomous cars are driving in the road, those vehicles need to have communication with the other devices very quickly and very reliably. So the data communication that must be very reliable and low latent. The communication data must be accurate and low latent. Because of that, we require specifically URLLC performance, and therefore we need a separate like slice of network resources that provide us that service, and that slice will be called as URLLC slice. So likewise, we can have different types of slice. And another slice we can have is MMTC slice. That means massive machine type communications slice. Massive machine type communications slice. In this case, we are talking about multiple sensors or multiple devices connecting to the network at once. So when we take IoT situations, we have like maybe 1 million of devices. 1 million of devices connecting to the network. 1 million devices or sensors, embedded systems connecting to the network. So in that case, the traffic that is coming towards the communication network is very high. In that case, the network has to be prepared for this scenario. So before doing this communication, we need to negotiate with the network infrastructure, I mean the communication service provider, on how we can reliably get the communication done. So therefore, the communication service provider will provide us a separate slice for our application, right? Anyway, these slices are logical slices. They are physically not seen. We can't see the slice physically. The slices are implemented logically using mathematical algorithms and softwares, right? So, however, all the slices that we implement are available in the same physical infrastructure that we have in the area. In a certain area, if we take for example, once we have a certain base station, who is a set of base stations that collect the requests from the customers, we'll connect to the certain local server, and that local server will send through multiple routers to another base, some kind of a collection point. In here they call that this is a central office. This is a central office. That means some kind of a local area network, and then through the multiple routers and switches, they will reach a more wider network, and then through another routers and switches, they will reach the core network, and then through the core network, they will send the data to the necessary destination, right? However, so the slicers are implemented in this same infrastructure. The slicers are, however, separated by using the uh, by using the different technologies such as software-defined networking, network function virtualization, network orchestration, network function chaining, and so on. So there are different technologies that enable this network slicing. We need to use those technologies to derive to give the necessary data rates and services to the customers uh, who are in the separate slices, right? So the separation of the services provided will be done through the SDN and network function virtualization basically, and network orchestration, and so on. So there are such kind of technologies that enable us to give the services uh, to each of the customers in a separate manner, right? So in that separate manner, when we give the services, we call that we are giving the services as slices. So we give the services as slices, service slice we call. So each of these slices we call service slice. So likewise, this is service slice 1. This is service slice. We don't call it 1. It is EMBB service slice. So enhanced mobile broadband service slice. So this is URLLC service slice. Likewise, we have different service slices, and different service slices are defined by different requirements. Each slice has a different requirement. Based on that requirement, the controller will control the traffic, and the network functions will be connected in a certain way such that um, the requested service is obtained. Likewise, network function virtualization and software-defined networking play a major role in providing flexible services to each of the customers who are requesting different services. So different services will be given by through different service slices. So with that, I would like to end today's class. So before ending, I will just give a small summary of today's lecture. So we actually talked about network, about software-defined networking. We talked about how it is, efficient and so on. So now we talked about network slicing. Network slicing is used by basically by different telecommunication networks, telecommunication service providers, to give different customers the required services. So telecommunication service providers uh, design the network such that they provide the customers the service they request. So the customers request different services. So customers can request high data rates, or they can request low latency, or they can request like massive connectivity, right? Massive connectivity. So based on their requirements, the telecommunication service provider will form the network um, such that the requirement is satisfied. So the different network resources, a set of network resources are combined into a slice, and that slice is provided for one application. Another slice is provided for another application. Another slice is given for another application. Likewise, we form slices and through that, we provide different like services to the different types of applications and customers who are using that application. So we'll talk about that further in the next class as well. So we will continue about network slicing in the next class. So thank you for joining today's class, and I hope you understood something.